morning, mathematicians, and welcome to week 18. We are looking at the column, and we are going to look at a lot of volume today. This is a great opportunity to practice that important standard that we already know. So we're going to take a look at this irregular shape, and we're going to be figuring out what its volume is. The easiest way to do this is to think layer by layer, right? So my bottom layer is a 3 by 3 array. I know that 3 times 3 equals 9, so I therefore know that there are going to be 9 cubes on the bottom layer. Now the second layer has almost exactly the same, but there's one less, right? There's a missing cube right there. So I know that that second layer has 8. Now the next layer, again, very similar, but do you notice it's actually missing 2 cubes from the layer below it? So I know that third layer has 6 cubes. When I go up to the second to highest layer, I notice that it's similar, but we're actually missing 3 from this layer below it. This one's missing, this one's missing, and this one's missing. So this one has 3 cubes, and of course the very top has 1 cube. When I add this together, 9 plus 8 plus 6 plus 3 plus 1, that gives me a total of 27 cubes, or 27 centimeters cubed. We're going to use some similar reasoning for number 2. Number 2 says, what is the volume of the below figure? I really had to study this one for the bottom layer. The top layer right here is very clear to see. My top layer has 4. 1, 2, 3, 4, right? So the top layer has 4 cubes. Now the bottom layer is a little trickier for me. I had to sit with it for a minute. It almost looks like an optical illusion to me, but I see 3 this way. 1, 2, 3. I see 3 over here. 4, 5, 6. Then I look at this row and I realize there must only be 2 because I'm not seeing it perch out right here. So 1, 2, 3, 4, 5, 6, 7. And then there has to be 1 right there. Okay. So we're seeing 3, 3, and 2. That's 8. Now there has to be 1 underneath each of these to support the cube that is standing on the top layer. So far we're at 8, but then I'm accounting for the ninth one has to be underneath this cube, the 10th one under this one, the 11th one, and the 12th one. So I know that on the bottom, there are likely 12 cubes. Now, if I stick with that thinking, then there are 16 cubes in all in this shape. Now, again, some of us might say there's one more underneath here. So if you said 17 and that was your reasoning, then I would accept that. Because again, like I said, it's kind of a little bit of an optical illusion, but I do believe it is intended to have 16 cubes, 16 centimeters cubed. Okay, let's go to our next one. What is the volume of the below figure? I can't count cubes anymore, right? So instead, I'm going to use my volume formula, which we've come to know. I am looking at a 4 by 2 by 3 prism. When I multiply this together, I'm really looking at like 8 times 3. Well, 8 times 3 is 24. So I know the volume is 24 cubic centimeters. I'm going to write that on my answer line, and I am done with that question. Now we're taking a look at this one. This reminds me of like gift boxes, maybe tucked underneath the tree at the holidays. But I'm looking at 3 different programs, right? We're going to calculate the volume of prism A and B and C to figure our total volume. We'll add those together. Now, a lot of the dimensions are listed, but right away when I look at A, I realize I don't have a label for what the height is right here, right? But I know that in all, this height has a height of 13, okay? Now, 3 of them are accounted there. 4 of them are accounted for here. That's what tells me this must have a height of 6. Okay, so now I have my dimensions listed as I need, and I'm going to be calculating the volume of A. So A is a 2 by 2 by 6 prism, right? 2 by 2 by 6. So really that's like 4 times 6, which I know is 24. And of course, that is cubic units. Now, when I take a look at B, I see that B is a 9 by 3 by 2. So I'm going to do 9 by 3 by 2, okay? And I know that this 2 is, let's see, actually, I need to change that up a little bit. I made an error here. So I do see a 9 here for the length, okay? I do see a 3 here for the height. Oh, and the width. So the width is over here, and it is a 2. So I see a width here of 2, but I see a width here, and yes, I was correct. That is a 2, and right here, that's going to be a 2 as well. So that's okay, mathematicians. Sometimes we have to look at things and question ourselves, and that's good. That's part of the process. So really, when I'm looking at this, I am looking at like 9 times 6, which of course is 54. So I've got 54 for prism B. Let's take a look at prism C. So prism C, we're going to be using these dimensions. The volume is going to equal 14, right here, times 4 times 2. So I see that too, of course, that similar width that all of them have. So when I take a look at this, this is like 14 times 6, actually, not 6, 14 times 8, because I have my 14 and I have it times 4 times 2, which is 8. So really, I can come to this side and I can figure what 14 times 8 equals, right? So I have 4 times 8, which is 32. Here's my 2, carry my 3. 8 times 1 is 8, plus 3 more is going to be 11. So I know that the volume for prism C is 112 cubes. Now, what do I have to do? I have to take my 112 plus my 54 from prism B plus my 24 from prism A. This is going to tell me that overall volume I have. Let me switch my pen. That one may have run out of ink. We have 4 plus 4 plus 2, of course, is 10. I'm going to carry that one. I have 4 plus 2 plus 1 plus 1 is 9. And then I have 1 plus 1 is 1. So my answer here to this question is going to be 190, and that is cubic. I'm going to put a CU for cubic, U for unit, 190 cubic units. The very last one is the combined volume of two identical cubes is 128 cubic centimeters. What is the measure of one cube's edge? We did a similar question like this a couple of weeks ago. And the first thing that we did is we said, okay, well, if it is 128 for both of these, I know that each of these is going to be half of that. So this is going to have a volume of 64 cubes, right? This is going to have a volume of 64 cubic centimeters, both of those. Now, the nature of a cube is that every dimension is exactly the same, right? So to figure that, I could go ahead and take this idea of 64, and I'm wondering what, when I multiply it together 3 times, gives me 64, right? So really, I should have a number. In this case, we could do just an S for side length times another side length times another side length times width times height, because they're the same number. When I multiply those together 3 times, it should equal 64. That's how we can say that the volume formula for a cube is side length cubed, and in this case, it's going to equal a volume of 64. Well, what number multiplied together 3 times gives me 64? You might have an idea of what this is already. When I take a look at this, I see 64, and I am thinking to myself that 64 is 4 times 4 times 4. And sure enough, it is. Because 4 times 4 is going to give me 16, and 16 times 4 is going to give me 64. So sure enough, I know that the cube's edge is going to be 4 centimeters. Every single edge will be 4 centimeters. That finishes out our Monday